I said at the beginning, I really have to thank the organizers of this meeting on asking those easy questions like, what lessons did you learn? Come on, I haven't slept this night. That's not so difficult, no? Because it really depends on trying to be honest with yourself and remember what you already knew. So you cannot trick you into say, I didn't know that metadata contain keywords. Of course I knew. The first thing that we learn is that there is a confusion on what a data space is and what is more important, how it should be implemented. So there are many preconceptions, as I presented before, and many hopes. In the website of the European Commission, there is a collection of hopes, for instance, but not really a direction on how to do this practically. We have tons of documentation, for instance, in the DSSC, and we have Gaia-X and FAIRware that has different interpretations on what is a data space, different interpretation from the International Data Space Association. For instance, this Pontus X that was mentioned by Raul. Not much geospatial consideration here. The IT guys has taken over. So now we are not in control. We mean the geospatial guys. That's a really uncomfortable position for me. What's the role of the OGC in this? Need or no need for connectors, no? We implemented the Eclipse data space connectors. That's actually the same technology that Simple uses, and we were able to integrate the data from the different sister projects in a single data space. From what I believe I have learned, it requires a considerable investment in software development. It doesn't say development, it says deployment. That is what it is. The development is there, but deployment is kind of not trivial. And it isn't clear if some big organizations will actually deploy those things or they will not see the return of investment. That's how we are now indulge ourselves in experimenting on alternative technologies, because we are scientists, so we are never sure that we know the answer. So we had this fact experiment at the end of our AD4GD project, and here a fantastic image that I asked the artificial intelligence to create for me, a wallet full of maps. Isn't that wonderful? So you will see this blue box in our policy brief that actually expresses precisely our willingness to explore alternatives. Anyway, we demonstrated that the connectors allow for APIs, and in particular the OGC APIs. This is really a lesson learned. We had no idea if this was going to work or not, but it works. So the OGC APIs can be assets in the Eclipse data connector like any other thing. It is easy to say, but then you try to generalize and the problem starts. For instance, if it's presented to me, the GB DataCube API. This is BCube, I believe, no? Doing that. Come on, they are doing asynchronous posts just for requesting data. I have no idea how to do this in the Eclipse data connector. And if it works, I have no idea if it preserves the sovereignty of these results. I don't know. In principle, FACS combines better with OGC APIs and should be compatible with all verbs, as I was told. Okay, semantic interoperability, as you have seen, is the core of many of our discussions. I would like to say there are many vocabularies up there, and they cover all what you need. That's not my reality. Every time that I need to look for a particular collection of terms, I solve the 90%. And then there are some things here and there that I'm not able to find the vocabulary, or what is worse, I find 7 different vocabularies with definitions that are kind of similar but different. That's, I mean, what IADOP tries to solve, I suppose. In any case, let me say that in principle, there is this possibility to create these linkages between terms, creating those relationships that should be able to allow us to do queries like, can those datasets be compared, or are those datasets measuring the same thing? As I said, I adopt is an approach that allows us for seeing in the details. So instead of saying, this is air temperature or air quality PM 2.5, allow me to say, this is air quality PM 2.5 predicted in those conditions, only valid in Berlin. Things like that. Because sometimes I need to be precise. Quality controlled. One of the things that in CTOps they want, differentiate air quality raw and air quality control. How on earth I'm going to do that? So I don't allow for this, profiling of the definitions. When achieved, it is fantastic, no? Because it allows the integration of in situ, citizen science, remote sensing, everything in a pot. Of course, APIs that implement semantic tagging, such as the sensor thing APIs, are preferable, and we have been practicing a lot on those. Machine learning, come on. What I'm going to say about machine learning that is honest with you. The first thing is, and it's not in the screen, the IT guys have a box full of MLAI algorithms. They pick one and they try it. It doesn't work, they throw it away. They pick another one, they try. I'm not sure this is a very scientific method, but anyway, after a while, and I'm saying this is kind of manual work, they train one particular model, it seems to work in a particular context. And it works better than other things, because maybe physical models cannot be applied there. For instance, the lakes in Berlin have behaviors that are not easy to model in a causal way. So instead we use historical data to actually predict the future, these kind of things, or the habitat connectivity in Catalonia. It's so complicated if you try to, in terms of amount of computer time, if you try to do it right, that maybe training an algorithm could work, and this is what we demonstrate, it worked faster. Is it better? Faster, it's faster. Okay, so the results of these models can be automatically included as assets in the Grindel data space. That's a good thing. We did that in practice, and even the models, trained or not trained, can be also included there in principle. How about the trust in the results? I mean, we have been discussing how to apply certificates to the training data in order to demonstrate that data is trustable. And then if we have a certificate that the training data is trusted and the algorithm is also trusted, maybe we can have confidence in the reproducibility of the results. That's something that we can be thinking about. Metadata is here forever. I'm sorry. I'm not sure that we will replace these things by anything else, despite the difficulty of making it right. Actually, the data spaces are based on catalogs that require metadata. That's what it is. Conversions between metadata standards are needed because they use different formats, because the IT guys doesn't like the ISO 115 for some strange reason. The federated environments means federated data. So if you have incomplete metadata, you will have a poor performing data space. That's what it is. You can throw LLM there and see what happens. I will not be confident, honestly. And this small detail that link from data to metadata could be achieved using file hashes. This is a detail, but to me it's important because sometimes you have a metadata record and you don't know where the data is, or vice versa. So achieving this link in a clear way, it's interesting. So those are some of the conclusions that well, lessons learned that we did in all data for creative.
So I've got, how many points? 6 points, 7 points. We will go through them fairly quickly. Starting with, wait, why is it not moving again? So starting with data availability. When we started with FAIRiCUBE, we were convinced there is all of this wonderful data out there. We're going to take it and we're going to do cool stuff with it. And I mean, it's true, there's all sorts of wonderful data out there. And whenever you know what you really need and you reach for it, there was nothing there. So, I mean, we spent at least the first half of FAIRiCUBE trying to figure out what data is available, what are we trying to do for the use cases, can we put together a use case where we can find all of the data we need for it. We did eventually, but it was not easy. And I mean, some of the reasons, there's all sorts of cool stuff under the Copernicus products. It's all nicely siloed into 6 different silos. And I mean, we were working on land and climate, and then we realized, wait, emergency's got some cool stuff. So it starts there, finding what is possible with climate data. Maria, you know this better than I do. I mean, we also thought, okay, ECMWF has this data, but the data we really ended up using was then some further processed data, which has been recalculated and is available via Google. So even if it's data you want, it might not be the way of accessing it you want. And further, the available data is very different by region. So you set up a nice system working on OpenStreetMaps. Okay, OpenStreetMaps you have everywhere. And then we started using CityGML. And then we started realizing how few cities have good, complete CityGML. So that also only works in certain areas. For further bits where the issue with data access, I mean, that's the one big thing which the data spaces should hopefully bring to us, is really clarifying access control, authentication, who's allowed to do what. And a further issue is the absence of efficient and standardized APIs and models, the amount of time we spend transforming data from this format to that format. We could have gotten a lot further if things were more standardized. So conclusion there, we need a green data. Structure and semantics. I mean, diverse formats are inevitable. We have different communities. We will always have different formats. One thing we will definitely need are transformation tools. However, I mean, and at the same time, I mean, what was not written here, I think, is that if you do use common conceptual models underneath, your transformation tools get a lot simpler, and the outputs are a lot more dependable. What we ran into with the gridded formats is that it's basically missing the relevant semantics. On good days, we would find what we call the observable property. On bad days, we would only have the data type. And all of the stuff we're used to in more terrestrial data of how was this determined, what were the devices used, what's the calibration, all of this is not even a topic. Serious amounts of information are lost in text. So there's too much freestyle keywords tagging that's so simple, so lightweight, I don't need to think about it. And I don't know what your keyword meant. And we've got 25 spellings of the same concept, and we are back to confusion. And quick plug for iAdopt, Barbara has now shown this to you. This would be a nice way of nailing down better what is really being provided there and also allowing for wider search. Because based on all of these individual concepts and then broader, narrower terms, I think that has great potential. And we really need it because, I mean, EO, until a few years ago, you only had the raw satellite data. Now you're finally getting products, and you've got a handful of products. But if you compare that with what we have on the ground, I mean, the water quality systems with 2,000 observed properties, and that will no longer work in the lightweight approach currently used of, let's put in 2 keywords and attach a PDF. That does not work. Next slide, please. Data transformation. This is something I had to put in here because everybody is now so convinced we've got Trido, and if we want to transform from this CRS to that CRS, we press the button and all is good. And with vector data, it's mostly true. With gridded data, it really depends on what the data is. And I mean, if you have continuous data, if you've got elevation grids, air quality, anything, you can nicely interpolate. You can reproject that as you like, and you should have fairly decent results in the transformed matrix. If you're dealing with discrete data or nominal data, I mean, population counts, you don't know in what part of that square, polygon, whatever it was. I purposely did this diagram showing also how different projections rotate. So there is no clean way of getting from here to there. You have to go back to the primary data and basically resample. And the same also goes with things like ordinal data. I mean, if you have your various land cover types, you cannot just statistically average between land and water and you get the code for wetlands. Be a cool system, maybe rethink it that way. Metadata. Okay, under FAIRiCUBE, we were using stack, and I mean, it's cool and it's terrifying. It is wonderfully flexible. Extensions are coming up minute by minute, and it is a true Wild West. And every time you look, everything is different. You no longer know what to use, what you shouldn't use, what interacts with what. Oh my God, I am by now terrified. So, I mean, it's a cool system, but it really would need some support, some governance, because right now it's just freestyle. One general thought is also applying metadata to processing routines. We're always talking about dataset metadata. We never really describe the various tools we use to do the voodoo to get the next dataset, and for proper provenance, we need reference. What is the primal data? What were the routines used? Why not apply a similar metadata approach also to the processing routines? And I mean, here are some further topics I've been pitching about generally: too much free text, first information on what it is, no information how you got to it. But I mean, that's the final point, which we're also going to sort of start repeating with our policy brief. We need to find ways of motivating people to provide metadata. As long as it's just a bloody burden and they have no benefit of this, they're not going to do it. Or they're going to do it miserably and we're all going to suffer from it. So that's a bit of a plug towards data citation, more on that later. Processing. So, I mean, one thing we noticed is that the data scientists, you give them wonderful stuff and you say, here's a cloud, here you can do all the processing of your dreams. And they say, but I know my desktop, go away. And so, I mean, we're going to really have to see how can we entice them. Are these wonderful cloud solutions just too clunky for them? Something's got to give there. I mean, you will be needing it because you do need the processing power. One serious issue that's a bit related is estimating the resource usage for all of this AI and ML wonderful things. Because, I mean, when we started FAIRiCUBE, we tried to estimate it, we couldn't. We're now trying to actually work through this. We've been recording the resource usage from all of our routines to try and get a handle of this. But I would be terrified doing a thematic project based on AI or machine learning because I have to provide some sort of resource estimate and I have no idea if it'll converge in time or if I'll just be left in my underwear. So that is something we really need to understand better. What is truly involved? How much effort do we need to do this? Data exchange, this has been one of my serious worries. I've been hoping that we have some nice standardized approaches for exchanging gridded data. I just kept finding things which don't work. And currently OpenEO is the most promising contender. I think that is being taken on board in OGC or not. I lost track of what the status of voting on that was. So there we really need to see, will that be our way forward? Is there hope for the other standards? I'm still hoping that OGC API coverage will land fairly soon. Then we would have a further alternative. Okay, and there's our final point, validation. And it's one thing which everybody tries to ignore and just hope it'll go away. It's always been like this. Everybody does perfect work. There is no need to test it. No. And what we've done in FAIRiCUBE for this, we really went through, said what are the relevant points which need to be checked, need to be validated, and put together checklists for each of these points. So we've got a clear overview what needs to be validated, and then can go through and also certify this processing routine has been properly validated.
Yes. Okay. So yeah, I'm gonna talk about what we learned from data harmonization in FAIRiCUBE. So we spend a lot of time. Yes. Okay. So let's say that our general work is finding data from different data producers. That can be climate data from Copernicus Climate Data Store, data monitoring data from Copernicus Data Monitoring Service, or from national or regional institutes like open data portals from the city or from some national institutes. And we want to combine them to do further analysis. So we take this data, we transform it and build an harmonized asset, usually DataCube, so gridded data. And if you are very good and we have time, we register also the asset in a catalog, and we do the analysis and we spit out results. So statistical, for example, statistical accounting, combining climate data and land use, land cover, and then present the results to our it can be the environmental agency, it can be the city administration that wants to know better the city. And then we get back from the questions, okay, but can we see the harmonized data? Or someone else wants to redo the process. How did you do the harmonization? How did you combine different data together? Or, okay, there is new climate data available. How do we combine this? Or we ask ourselves like a month later or a year later, okay, how did we do that? Okay, then you can go back to the catalog, check your harmonized asset, say a DataCube that can be stored in many different formats and so on. And we check the metadata. Okay, we maybe added a bit of a description, but we actually need to go back and modify it. So basically, we throw away what we did, our harmonized asset, and we try to figure out all the steps that we did to recreate it, maybe slightly modifying some parameters, adding new data, and so on. So I think after iterating on this process, we realized that there must be a better way. So what we think is better is not to store artifacts or assets or share those as people ask them, but think rather in terms of recipes. I'm saying general saying recipes and not code or script, because recipes can also be other things, can also be configuration files and so on. In general, it's like a recipe, a description, like first of all your input data and a description of all the harmonization steps that you took to do to get to the harmonized artifact or asset. So I think that's what we really see is the way forward for us that solved the questions that we have before. Can visualize the data is always the problem, that sometimes you need the same data but in a slightly different format. So to visualize it rather than analyze this, we know exactly how we did the harmonization, and then we can adapt it. So go back. So the advantages that we see in working with recipes rather than fixed or offline, let's say, assets, is that of course a recipe has a smaller footprint, because we do not take the original data, we combine it together, and it's almost duplicated and save it somewhere else. But we just have a recipe. So it's faster to share, and it's also system agnostic, so you don't lock in yourself in different data formats and enter this complicated world. And in principle, you have all the information and also the metadata already in the recipe. Asterisk can come into this later. And then it's faster to update a recipe because you can see where you want to do the update, for example, add new data. And of course, in the recipe, you also have the information where you got the data and how. So which API did you use? Hopefully, there is an API, or where you downloaded the data, at what time, and so on. So it's faster to update and to adapt to different contexts. About metadata, I know it's the hot topic. The question isn't how detailed should be your recipe, because take an example of the reprojection. So you have different reference systems, and you want to reproject to a common reference system. Reprojection, as Kathy said, is simple. When you look at it from far, it's very complicated when you look at in the details. So you can just say, okay, I'm going to reproject from WGS 84 to the national Austrian projection system. Okay, or you can be more specific and saying that you did it with the GDAL translate. Or you can also say, okay, I use GDAL, but I also use these parameters. For example, I use this interpolation method, I use nearest neighbor, or I use linear interpolation. Or you can be even more precise and just provide the script. Can be a Python script, can be a shell command using GDAL, where you just see exactly step by step what has been done. Of course, this is a lot of information because if you are just talking about one step, reprojection, it's okay, digestible, but if you are adding a reprojection, clipping, transforming some variables, deleting from other, doing resampling in time, and so on, it can get very long. And then if you're using some non-standard tools, so if you, for example, went beyond GDAL and want to work with multidimensional data and do some non-standard, for example, Python libraries, it can get really complex. But in principle, the recipe here, for example, I'm talking like a Jupyter notebook for people, for developers that like Python, or can be a configuration file in YML or a JSON, for example. It has all the information available, which can be a lot. And here, maybe like a question to the audience is there a way to leverage the new language models or AI to simplify this? So we provide instead of providing the harmonized asset, we provide the script. Of course, it's just a part of it. Of course, you need to provide some more metadata. And it's a lot, but maybe you can have interfaces, different interfaces that provide summaries for like a quick overview for people that don't want to dig into the complexity of scripting or are not familiar with the programming. So that was my lesson learned, and I think okay.
So I will do a very brief intro to the like some of these lessons learned that we have in coming from usage. In fact, I mean, like I have not prepared directly slides, but just 4 points, yeah, that I would like to share with you. Yeah. So this is mostly what I will be doing. Give me just 1 second, and you should have it here. Okay. So basically, I mean, like, which are the main messages, yeah, that we would like to stress. So probably, I mean, as one of the lessons learned that we have from usage is actually the fact that the concept of data spaces is still something that is a little bit unknown to most people who are working, especially in the public sector, which is the main focus that we have in usage. We are, remember, working on urban data spaces, yeah, on local Green Deal data spaces, yeah. And I think, I mean, that one of those main messages or main lessons learned that we have from that is actually the fact that we should stress, especially for public sector employees, which are the opportunities, the challenges that come in whenever we are moving from open data to the concept of data spaces, okay? So in general, they are still, I mean, whenever we are talking about data sharing, for them, I mean, their mind is still thinking of when they immediately they are trying to share data, maybe sensitive and types of quality.
We're losing you.
Yeah, Oscar, we're losing you.
Is it related with the wind?
Yeah.
Oscar, we are not.
It is confirmed that we have
Hearing
lost
you.
him.
Yeah.
Yes, not.
No, are really broken. How to say
We
it?
are not
Used to. Problem.
hearing you well.
So yeah, if I cannot connect, if you cannot hear me,
Now it's
I
better.
don't know what to do. Yeah, I mean, I will.
Now it's better. Now
You
it's
are
better.
coming back. You are
Yeah.
coming back. Try it again.
Okay, I mean, I'm in a public space. I mean, like, it should be okay, but I'm not in my office. Yeah, so that's so I will. I mean, I'm just taking out my video connection. So
Now it's better that you are not
Okay.
sharing me, but it was like
Yeah.
was that. Yeah.
Please continue. It seems
Okay.
that it works now.
okay. Well, I mean, if I drop out, I mean, like, you can continue then without me. No worries. So, I mean, what I was actually commenting is that my first point is actually related to the importance of making quite clear to public sector employees, especially whenever we are talking about data sharing, we are not just talking about open data, yeah? Because I mean, this makes them sometimes reluctant to share some of the data sets that they are working with. So I mean, it is quite clear that we have to push forward this message of moving from open data to this. Okay, you have to take care of.
No.
Every time that you say something interesting, we are
Oh.
Stick to the boring stuff.
I mean, I'm available just for anything else. No worries.
Okay. So maybe we can go to the.
Show us the
You'd like to
document.
be on
It's a
the-
good document.
It was a good document.
Yeah, you
yes.
can share the document or send it to us, and we can
Distribute.
show it on the screen. Okay, in the chat it's fine also. But thank you.
Oh.
Mira.
Oh, yeah.
Can you make it bigger?
We can make it bigger,
Make it
not sure,
bigger?
but I can take it in a Word and share screen.
Print it out, hand it out.
Sit on what has been decided is the panel here
Yeah,
against the
please.
wall, or shall we just kind of generally question?
Well, don't ask him.
Just go, just send it. Come on.
I'm coming.
Council.
Here we go.
Right. I had some questions. I had lots of questions about all these. Thank you very much, everyone, for these points. And one of them, I'm going to start off with a question and then see who else wants to keep up on this. So there's lots of talking about AI, what AI can do for us, and it seems like it could be really good, for example, looking at our text and telling us what might be a useful vocabulary term, things like the Onto portals already do. But maybe to be a devil's advocate, the thing about the reason it's painful to write metadata is because it makes you think, is because it makes you articulate your assumptions, and it makes you talk about what you did, and it makes you talk about why you did it. Is it morally a good idea, morally or scientifically, a good idea for us to pass that over to LLMs? How far do we need a human in the loop? What do you think about this?
I mean, to me, the question is the other way around.
Okay.
I believe that artificial intelligence will never guess what we have done with the data. But if we have a long collection of recipes, as you told us we can have, then we can approach a trained LLM and tell her, well, I have this data set here, this other data set here. Give me some recipe to actually harmonize this. If we had enough, we could probably train an algorithm to actually provide us with clues on how to do that. I believe that's the right way. I mean, we cannot expect that the LLM creates the knowledge, but we can use that technology. That's my way of understanding artificial intelligence.
Could we, if we feed an LLM system with keywords as we are working? I did this, the simple protocol of the steps, and then get the LLM to somehow juggle that into a sensible shape. I think that could be a compromise level. That we do feed in the facts, the LLM then figures out where in the metadata structure does which fact fit nicely.
I have a few things to say here. First is, well, regarding the, recipes thing that was more or less talking, introduced, I think that this very much aligned with the concept in AD4GD that we have for our pipelines. The pipeline is basically a recipe that tells you how to do the harmonization. And as I mentioned also, one of the things that we have been working on recently is the use of LLMs to, create this like recipe a little bit semi-automatically. So we have a very good results even with the generic LLMs in order to provide that. Why? Because we have like also like structure, right? So we have like this kind of recipe that tells you, okay, I want to have my data harmonized according to this model. So here are an example for you to take as an input, and this is my new data, and I want to have something like this. And this is like the specification in which I want to express the new recipe. And so the LLM is not bad. It is really producing a very good output without even having specifically trained for that, just by giving some good examples. And we are getting, of course, not perfect. This always will require some user interaction at the end to make sure that the actual recipe, and for example, the connection with the observable properties or other artifacts that we are aligning are actually the ones that we want to use, right? But the LLM is giving you some initial propositions, and many cases are good. In some cases, we need to adapt. But this is a good thing that we are trying to do also for the next projects, how to make this as a service that will continue facilitating this process.
So we have a question.
No, actually, I just wanted to add a couple of comments to what Raul said. Well, in any case, LLM is as good as the training data provided to it.
So the good examples is really key, right?
Yeah, exactly. And if the data is well structured, including metadata, etc., and it has like key value, it will give you the result that is structured as well as the original data. One thing that you underlined the moral question, right?
It was kind of.
Yeah, but it's a really good question because, well, if you work with sensitive data, etc., you will always have. Don't remember the exact term, but it's like a bias that is introduced into the result. Again, it all depends on the original data, training data. So it should be unbiased already. And the way to achieve it, in some sense, is to anonymize the data. So if you just want a recipe, right, based on some kind of data, you anonymize the training data. And that's it. And you will get a recipe for, let's say, similar data that you want to process that doesn't care about the actual content of the data, only the structure, key value. So the value is anonymized.
You've got a comment on that one.
So that's an interesting point. I want to connect that point to what Kathy was saying about validation. and validation might be mechanisms to help, because several people have commented about bad metadata or mismatched, misaligned metadata. That's something that LLMs can probably do a pretty good job of assessing, if it exists, to say, well, it's really out of whack compared to these vocabularies, these ontologies, these I adopt principles, blah, blah, blah. If there were independent validations metrics for processes, the whole pipeline, the whole script, there may be a way of saying, well, how can we improve the process because we have some validation? We come around to the training and say, well, what an LLM does is say, okay, well, I have some expected results from the training data, and I'm going to create a model to reproduce those results. It actually doesn't know what it's doing. It's just saying, I'm coming up with a better averaging function to give you the number you were looking for. So it's not actually making a value judgment about the data. And so what it does to the inference data is, unpredictable. So it'd be better if there were validation data or some kind of separate measurement that said, oh, this is what we're looking for. This is a good result. This is a bad result. This is something that can be reproduced. This is something that couldn't be reproduced. Those are the kinds of things that you could feed into an LLM and say, oh, train against this, reproduce this, do something better with that, fill in the gaps on the metadata or improve the metadata this way. So you could give it some useful narrow tasks to do based on that independent information. But you just sort of, that was just one slide, so I don't know if there's more underneath all that validation, but that sounds like a good thing to have, and then a good thing to feed in.
I mean, there's more really just manual checklists. What have you forgotten? Nothing automatable. And I mean, as Joan was also saying, I'm wary of what we can really pass off to an LLM. Mm-hmm. Yes, it will invent something, but that's not what we need in fact, and not just somebody's fantasy, something's fantasy.
More questions. Fantastic.
Yeah. I'm putting on the GEO data management working group hat because it sounds to me like the good data management principles is even more important now than ever. And the metadata, concerning the metadata and the moral, whatever you call it, ethical or moral, it's the metadata, even if we produce it automatically, the human factor will always be there. So even if we try to be unbiased, we will be biased, and that will be either enhanced or reduced, depending on how clever our systems are. So I don't know, you named it, the LLM is not better than we make them, so even artificial intelligence, to me, is not scary at all, in the sense that it's as good as we make it. But there
That's
are
what's
factors.
scary, is that we have a capacity to make it quite
Yeah, exactly. So there are factors like, it comes in also where you come from, there's what you call it, indigenous knowledge. You have, what kind of words is that captured by the systems that we are using here? Gender is another, so there are many factors that needs to be included, and maybe a question for, if you have reflected on this, you in this group, how you can capture that using, for instance, all this, GEO, fair, care, and trust principles, if that's a way to incorporate a bit of it also in data spaces.
I noticed that all of you have mentioned sort of provenance or lineage or documentation of processing of services. In Oscar's as well, I see metadata for services. And I remember that at least two of you have said to me that it's very easy to lose that provenance information when we start doing interesting things and moving across platforms and across solutions, because not all of them, especially some of the more commercial ones, are designed to ingest metadata and to add to it. And I wondered if any of you have ideas, how can we incentivize participants in the data space and solution providers to actually take metadata on and at least not throw it away, and potentially even add something that says what their system did to it. Is there anything any incentive or any kind of tool we can use to make that worthwhile?
I mean, what you're
Or do you
describing
have the
sounds a lot
documents
like
and
CREAF. And I mean, you're describing sounds like CREAF, that you have what are the underlying data sets, what are the processes I performed on it. And I think we would really need to get the CREAF structure into various metadata systems. I mean, right now, 115, it has lineage where you then write all sorts of prose and maybe mention some other data set.
So then would there be kind of easy plugins that any commercial provider could apply that to their system? I'm thinking, you've got something like Minio, you bring some data in, and you run some PSNC, they do a machine learning thing, and their system isn't necessarily set up to use any particular standard of metadata or to add a process step or whatever. CREAF would be easier, you're saying, because it would be an operation is they're the agent, they do an operation on, I can't remember, an entity, the entity that they received. Okay.
And I mean, it's related to trying to transform between different metadata systems, which we will need to be able to do. And I mean, we've got 115, the DCAT has been mostly set up, but Stack is right now developing faster than anybody can map that. And BCube has been focusing on the EPV portal. I mean, those are, again, 4 different systems. We will need to transform.
So this is me speaking for Sage.
Right.
I think it's fair for Sage to make that a requirement. It has to be a requirement that there needs to be validated metadata when data is presented to the Green Deal data space for potential use, or that there are mechanisms for taking unvalidated data and to validate it. And we have lots of non-standard stuff that people want to put in and work with. Second, that all transformation services, et cetera, any kind of combinations of data, there should be ways to capture that in prov-like stuff in the metadata that's associated with the data. And if it's going to go back into the data space, it needs to have all that stuff there. And presumably it can be independent, this is a different word, it can be validated to say, yeah, that's a complete record, or no, it looks like somebody made stuff up at some point along, there's a gap. It's like your CV. What were you doing for the last 2 years?
I think maybe it's easier to incentivize publishers, because for them, if they produce good metadata, it increases the chances of citation. So they can show the value of their work, they can get more funding, they can show how useful their work has been. But then for the interim processors, I'm wondering what can...
The risk, that's all lovely at the published stage, but the risk for all the sort of work in progress on data and the stuff that the sort of practical value added that commercial entities want to do with data, they're going to say NFW.
Yeah.
I just don't have the patience for that.
Yeah, exactly.
So we need tools to make that easy for them, ideally. And we can work within our use cases in Sage to say, you need to make sure this happens, and then ideally provide tools to other use cases to say, this is how you can make that happen. We had somebody doing this in the European Open Science Cloud in EOS-Beyond, and I said, are you doing all this automated processing in Jupyter Notebooks and so on? Are you keeping track of the provenance metadata? He says, no, we plan on doing that, but it's just a bunch of fiddly scripts and stuff. So it wasn't exciting for them, and it wasn't done.
So in the Sage project, will you be producing tools that will make it easier, for example, for people to find candidate URIs, to tag their data, to actually kind of maintain this provenance as well? Or do you already know what tools? Will you be extending?
Hope springs eternal.
Yeah, okay.
I mean,
Do you know
we're not in the business of
components
creating these
that can be
tools, but if the
integrated
tools exist, and they work, we can point to them and make them available.
If I may, there are 2 models of working here in these infrastructures. There is the all SDA way of working. I go to the SDA, I download what I need, goodbye.
Yeah.
So then you have no idea about the provenance of the new results or whatever. Then we have the OpenEO way of doing things. I take a couple of satellite information and I press execute, and the result goes back to the catalog. You cannot avoid that. So that's a completely different model. Immediately your result get public, and the system can add metadata and can add provenance, and you
your
need
recipe
to
as
review.
well. You have your whole
absolutely.
Yeah.
So what is the model we want for data space? The SDA model or the OpenEO model? That's the question.
So I can comment on the thing which was done in usage as Oscar is maybe not solvable. And it was usually a mix. Because simply some of the data is processed on somebody's desktop, and some of the other data is processed on somebody's cloud. And then the whole, well, quite significant exercise was to document all of this processing chains in the BPMN standard format. And based on the BPMN, the governance was provided at the end. Which is now going to be linked back to that. Then we have also the assets. So in the BPMN, we have the ID of the assets and IDs of the tools, which are in the GeoCAD. And then you have this link store.
So is the BPMN kind of sitting on top of existing bits and pieces of metadata and bringing them all together in different standards?
BPMN was, and that's coming from this comment from Oscar also, that actually the whole process was for the whole project co-design. So actually, it was this BPMNs were being shaped through this project, and they finalized, I don't know, a few months ago. Well, they started more than a year ago. So all of these BPMNs were the idea of this processing flows, and then just it was updated with the new entities. It was full manual process. I mean, but it required this. I mean, this documenting in the BPMN was a manual process, while documenting it from the BPMNs to the provenance chains was actually automated. The validation of this was also automated, so at least you can see if there is any assets missing, and the full metadata in this workflow is available. And then somebody needs to draw down.
Business process modeling, BPMN, business process modeling.
I was thinking about a lesson that I learned, but I think it might apply to you guys as well, in terms of what stakeholders want. Like, we have an idea of what the stakeholders want, and there's an example in our project where, for example, we're looking at lake quality, and I had the impression that that they were going to want some numeric value. It was going to need to be on a kind of an absolute scale. And in fact, what they wanted was a ranking. They were not at all bothered about the actual value at the lake. It was just which is the one that is most important that we need to go and look at. And that was a real surprise to me. And I was wondering if any of you, Oscar, as well, online, did you have any surprises about what stakeholders want when for any of your use cases, or did you find that you had already conceptualized it quite well?
I can relate to what you said. That's we had a project with city administration, and they also are interested, rather than absolute numbers or the science behind, like really actionable information. What is the most important value here? In which area of the city should I be looking at this phenomenon is happening more, and so on, rather than absolute numbers. And they want more visuals, communication, like easily digestible information.
Mm-hmm.
That's some.
Any others? Any other surprises? Okay.
Oscar?
So not sure if you hear me now, yeah?
Yeah.
But, okay. But basically, I mean, obviously, I mean, when you talk to stakeholders, you will get new insights, new needs. And clearly, I mean, like in this context, I mean, we had use cases that we had started with that we thought that they were going to be, I mean, like focus on some specific topic. I mean, for instance, we had the case of urban heat islands in the different cities where we are working. That initially, I mean, we thought that basically, I mean, we just had to identify them, and then, I mean, there would be some action on them, yeah. And suddenly, I mean, like just by talking to stakeholders, we realized that there were other different needs, yeah, rather than just the visualization. I mean, obtaining, processing, and getting the visualization of the urban heat islands. I mean, they just wanted, in some cases, to connect it to the vulnerability of people living over there. So, I mean, clearly, there will be always new things that are coming up if you take it seriously. I mean, that was one of my main messages. Let's not do just a technology push, which is super nice, but sometimes, I mean, it is not what we really want. But just talk to stakeholders and get it. I mean, like from the problem. Yeah.
Yeah, that's a nice point. That technology push, which you had in your comments as well. I think we've got to the end of the time. We extended the time a bit, but we've got to the end of what was allowed.